All right, number 15 asks us to find a derivative two ways. First, we're going to do it straight up just using the quotient rule in this particular problem. Then it wants us to kind of redo it algebraically and make sure that we get the same result. I was going to skip that, but as I look at number 15, I think there's something cool that happens. So let's do this one, what we would consider kind of the straightforward way. H of t is defined as t squared minus 1 divided by t minus 1. That clearly is a quotient with a variable on both the top and the bottom. So I would find our derivative, h prime of t, by doing the quotient rule. And here we go. The denominator is t minus 1, and we'd multiply that by the derivative of the numerator, which is going to be a 2t. That takes care of that, minus the numerator, which is t squared minus 1, multiplied by the derivative of the denominator, which is just going to be 1, all over our denominator, t minus 1 squared. And let's see where that gets us. We're going to kind of backwards distribute that 2t into that first binomial here and get a 2t squared minus 2t. And then here, multiplying by 1 doesn't really accomplish anything, so we're just distributing that negative to get a minus t squared and a plus 1 all over a t minus 1. So everything we've done so far has fallen within the realm of the reasonable things I would expect you guys to do, and so with the next one, which is combining like terms. Not much, though. A 2t squared minus t squared is just a 1t squared minus 2t plus 1 all over a t minus 1. Oops, I forgot to square that on the last step, and there we go. And in an awful lot of the quotient rule problems that we do, this is where you would quit. Very often, not much happens. However, this is a special one right here. The best thing that could possibly happen for us right now is that the numerator could factor. And in fact, this one was, where it does factor. We get t squared minus 2t plus 1, which, let's just see where this gets us right here, but those numbers certainly make me think something's going to happen. Split the t squared into t and t. Signs are the same, and they're both negative, so minus, minus, and two numbers that multiply to 1 and add up to a negative 2 are negative 1 and negative 1. That numerator just so happened to be a perfect square trinomial. It factors into t minus 1 squared all over, the exact same thing, t minus 1 squared. So that t minus 1 cancels with one of the t minus 1s on the bottom. That t minus 1 cancels with the other. And when everything cancels, we just end up with a final answer of 1. Now, the fact that this numerator right here canceled and that this expression simplified tells me there was probably another, maybe smarter way of doing this problem. And to figure that out, guys, that is what they're getting at with the second thing they asked us to do here, which is to simplify the function algebraically. If you notice here, I'm back up to the original function here, t squared minus 1 over t minus 1. That t squared minus 1 is a difference of squares. It factors into t plus 1 times t minus 1 all over t minus 1. And sure enough, the t minus 1 on the top and the bottom cancel each other out, which means the value of the original function, h of t, simplifies into just t plus 1. So if that's a better, simpler way of rewriting the original function, h of t, then h prime of t will just be the derivative of that, which of course we can just evaluate using the power rule, or just remember that the derivative of a linear function is its slope, and the coefficient of that t is 1. So this shouldn't surprise you, everybody, because this is not humanities. There's not two different answers to this problem. You can do it two different ways, and as long as you're following the rules of math in either case, we're going to end up with the same answer here of 1, no matter how we slice it. Now, obviously, the second way of doing that problem was a lot faster and a lot easier. So let that be a lesson to you, everybody. If it is possible to manipulate and simplify the original expression, you are almost always better off doing that right off the bat, whittling it down to something simpler, and then taking the derivative of that simplified version. If you don't see that the original function can be simplified, the other rules we're working on, in this case the quotient rules, still work and will still eventually lead you to the right answer, but it's much, much harder, and you're much more likely to either make a mistake in getting from point A to point B, or just not realize that you can keep simplifying and get your derivative down to something quite that easy. So that's problem number 15.